So hello everyone, today we are seeing this question, that is find the prefix common array of two arrays. So in this question, initially we are given that you are given two zero-base index integer arrays of permutation arrays of a and b of length n. A prefix common array, basically a definition is given. A prefix common array of a and b is an array C such that C of I is equal to the count of number that are present at or before the index I in both a and b. So we need to return this prefix array of a and b, and this is the definition of permutation, that is in an array a sequence of n integers is called a permutation and it can only contain number 1 to n exactly once. So let us see the sample cases in order to understand what exactly the question is saying. So let's take this example. Initially we were given two arrays, that is a and b, and we need to construct the array C which has some values x1, x2, x3 and x4. So basically what the question is saying, let's proceed it index by index. So initially let's take for I is equal to 0. For I is equal to 0, A is equal to 1 and B is equal to 3. So like in A and B there are no common elements. So the x1, basically this prefix common array x1 would be 0. For I is equal to 1, A and B, A is 1, 3 and B is 3, 1. So there is basically 2. So this would be 2. So basically x2 is 2, this is 0, this is 2. And for I is equal to 2, till I is equal to 2, we need to consider the array 1, 3, 2 and 3, 1, 2. So basically there are 3 elements which are common in them. So answer is 3. And similarly for 4, all this equal. So our answer would be 0, 2, 3, 4, which is given as per the question. This is 0, 2, 3, 4. So basically we need to find this array on the basis of A and B. And as we can see in the given question that constraints are very low, so we can also brute force it. First intuition which came into my mind is like n is small, so we could solve n cube solution, so it would not matter. So I would start with a second approach, that is O of n square approach, which is more convenient. So basically I thought of it for every index, for ith index we can maintain a data structure which gives us the distinct count. So like after seeing the given questions, so like there is only two data structure which gives basically a distinct count. According to the given question, we could use set or unordered map. So I thought of using unordered map. So what was my approach is like while iterating through the elements I0, I less than n, I plus plus. While iterating through the elements, for every ith, I basically push the element a of I in my map and b of I in my map. And as given arrays are permutation. Permutation means let's take an array is, permutation is the array would contain 1 to n only, take anywhere 1 to n in any order. It cannot have 1, 1 in it or 1, 2 in it. Let's take a for example, let's take a permutation of 4. So what would be the possible combination? 1, 3, 3, 4, 4, 1, 2, 3, like this. This array cannot contain 2 once or 2 twice. It can only contain once. So by this I can find that when elements are common, it will be common only if the frequency of it is twice. So while processing that, I can write a for loop for iterating it in basically the map. We can iterate in map and find if the x dot second, basically the frequency count, is equal to 2, then we need to maintain a variable int common up to that I would be 0 initially, and we can increase this common plus plus, and after this for loop we can just push that in our answer dot pushback in our final basically C array, C dot pushback, whatever is this common, and we can return this. This was my first intuition after seeing this. So let's take this basically see the code for it. So this is the code for it which I was explaining. That is initially take a unordered map in order to store it, and then while processing this whole size, then maintain a common variable to find all the common elements up to the ith index, and then iterating through this map, and whenever the count is 2, we will increase the common count and then push it into the array, and then I'm returning this array. This was my first approach. So this first approach, time complexity, was like initially we were going through the whole array, that is O of n, and then iterating through the maps again. So like at max it can contain that all n distinct elements. So this is also n. So the whole time complexity was n square, and space complexity was also n, because like in the hash map we are storing all the elements of this basically, as it is permutation from 1 to n. So like at max we will store all the elements twice. So it would be 2 times n, that is order of n only. So after seeing as the time complexity of O of n square, like for the given constant that is like n is 15, so it would work perfectly. But like let's say the n was like very high, like 25, then what we would do, like we would need a O of n solution, which is also possible in this case. So my second approach was, we need to make an observation for it, like for every index ith, we just need to find the common elements, right? So like let's take whatever the test case was, like 1 3 2 4, and p was 3 1 2 4, that is 3 1 2 4. So second approach was like we need to eliminate this second loop, that is this for loop, like while iterating it, we need to remove this, like as it was leading to n square complexity. So what we can do is, for every index, like till this index, how many distinct elements can exist? That is 2. Till this index, how many distinct elements can exist? That is 1 2 3 4. Till this, how many can exist? 1 2 3 4 5 6. That is 6. And till there, like 8 distinct elements can exist at max. I'm telling at max. So like you can observe this pattern, you can just make this formula, that is 2 times I plus 1. This is basically total distinct element which can exist till now, till ith index. So what my observation was, like for ith index, we can find the common elements as, common element is equal to total distinct elements minus number of distinct elements found till then. Like let's take this example 1 3 2 5 4. So like till this 1 and 3 are found, that is 2, and this is also 2, so 2 minus 2 would be 0. Till this 1 3 3 1, this basically there were needed 4 distinct elements, but the map would contain only 1 3, as like it would only have till this index it only have this thing. The 4 minus 2, it would be 4. Let's take till this index, like 1 2 3 1 2 3. So it would the map would contain 3 elements, that is 6 minus 3, answer would be 3. And this element, answer should be 8, would be 4, like it would only contain 1 count is 2, 2 count is 2, 3 count is 2, and 4 count is 2. So answer would be 8 minus 4, that is 2. So this was my second approach. Like for ith index, I just made a formula, that is common is equal to 2 times, like this is the max possible, minus the currents having. So this was my formula, and this is the approach which I was talking about. This is basically take this answer array, then make an unordered map, then fill that map, fill it, and then for every common element, as I'm using zero-based indexing, so like I have used I plus 1, you can, if you use from 1 base indexing, you can also use like I. So basically whatever the formula which I mentioned, that is this, that is 2 times I minus 1 minus h dot size, basically the distinct element till now, and then I'm pushing and returning this in, and the time complexity of is O of n, as it is computing, this is O of 1, and space complexity is O of n, that is O of 51. This is simple, and as like the given n was like small. So this was my solution. Thank you for hearing this.